Hi there, this is Mr. Sutton bringing you this lesson on arc length and sector area for circles. In this one, we will be calculating arc length and sector area and using this in a real-life problem to find the diameter of a planet. For your warm-up on this one, see if you can find the circumference and area for this circle below, and you can leave your answer in terms of pi if you want. Alright, let's see how that went. So for circumference, we have circumference equals 2 pi r for that formula. The radius here is 6, so this is 2 pi times 6, or 12 pi. And now for area, we've got pi r squared for that. So that's going to be pi times 6 squared, or 36 pi. Now the follow-up question here is, what if we want to find a fraction of the total circumference or the total area? How could we do that? Our general strategy on this one is we're going to use proportions, where we know part of the circle and the whole circle, usually the angles here, and we either know the whole circumference or part of the circumference or part of the area or the whole area. So this is the direction we'll be going with all this. To go any further into this lesson, we need to know the difference between what is called arc measure and arc length. These are not the same thing, even though they look like they'd be kind of similar. Arc measure is the measure of the central angle. It's a measurement in degrees. This is what you've been finding the last lesson or so. This is always out of 360 degrees. For example, on this circle, you would have an arc measure for BC of 68 degrees. Now, arc length is a little bit different. Arc length is the actual distance of the arc. So this is just a piece of the actual circumference, and there's distance units. For example, we could say that the length of arc BC is 125 centimeters. Now, even though arc measure and arc length are not technically the same thing, they are very strongly related. The bigger your arc measure is, the longer your arc length is going to be. In fact, arc measure and length are proportional. We can set up a proportion part over whole equals part over whole. We can say that the arc length, the piece of the circumference, over the whole circumference equals the arc measure, the piece of 360, over the whole 360 degrees in the circle. Let's use what we've just learned to figure out the length in this circle of arc AB. Now, thinking back to our proportion on the last page, we could say the length of AB over the circumference equals whatever the arc measure is over 360. So in order to find this arc length, we're going to need the arc measure and the circumference. I mean, we already get 360 degrees for free, but we need these other two things. Let's talk about the circumference first. They didn't tell us the circumference. They did, however, give us this radius. So we know circumference is just 2 pi r. So in this case, it's just going to be 2 pi times 8, or 16 pi. For the arc measure, they actually gave us this central angle here of 60 degrees. So now we can put all this together into a proportion. We can say the length of AB over the whole circumference of 16 pi equals 60 degrees over 360 degrees. And at this point, we just have to cross multiply and solve for the length. So pause the video and take a sec to do that. See if you can remember the algebra here. All right, let's see how it went. So I did kind of a middle step of doing 16 pi times 60. So that would be 960 pi over 360 degrees. I will need my calculator at this point, though. So I've got 960 pi times divided by 360 comes out to about 8.38, and that'll be centimeters. Here's another example. In this circle, we want to figure out the circumference of circle D. Pause the video and see if you can do that. So on this one, if you're looking for circumference, you're going to need to know the arc measure and the arc length. Now, as luck would have it, we have the arc measure here, and we have the arc length here. So we can just set up a proportion. We can say that 4.19 over whatever the circumference is, we'll call it C, equals 40 over 360. Again, we're just using proportions and ratios. So cross-multiplying, we've got 40C equals whatever these two things multiply out to, calculator time. So 4.19 times 360 is 1508.4. And then I have to divide that by 40, so let's do that now. So I just press divided by 40, and it does answer divided by 40, which comes out to 37.71. What's our units? Inches. We're going to do one more problem involving arc length. In this one, they want us to find the measure of arc RS. So we're looking for the degrees this time. Pause the video and see what you can make of this one. All right, if we're looking for the arc measure, that means we need the arc length, which we have. It's 44 meters. And we need the whole circle, the circumference, so we can set up a ratio. Now, we don't have the whole circumference yet, but they did again give us the radius. So we can again do 2 pi r, in this case 2 pi times 15.28, which is going to be 30.56 pi. Setting up our ratio now, we can say 44 over 30.56 pi equals the mystery angle here over 360. And cross multiplying, actually we just have to multiply 360 to the top here, because then measure of angle RS will be all by itself on the right side. So 44 times 360 gives us 15,840. We just have to divide that now by 30.56 pi. So go ahead and do that. And if you've done this correctly, you should get a value roughly equal to about 165 degrees. Wait a sec, some of you might be saying, I didn't get that number. I got something like 1,628.36 degrees. What could have gone so horribly wrong? So what may have gone wrong here is you might need to use a parentheses in your denominator on your calculator. So I'll show you on mine. So I've got 15,840 divided by, and then I'll open a parentheses, and we'll do 30.56, and then second and pi button over here, close parentheses, equals, there's my angle of roughly 165 degrees. Now, why do we need to do this? Well, it's a PEMDAS issue with your calculator. If you don't put this parentheses in here, your calculator is just going to do multiplying and dividing from left to right, which means it's going to do 15,840 divided by 30.56, and then whatever number it gets from that, it's just going to multiply that by pi. But you don't want that to happen. You want this multiplication in here to happen first. That's why you need to use that parentheses. We're going to shift gears now to talk about sector area. So if you think of the arc length as kind of like the crust of a pizza, the sector area is an entire slice of pizza. It's a pizza slice of the circle. And we can have major and minor sectors just like we can have major and minor arcs. For example, in the diagram over here, we could talk about minor sector AB. That's this shaded slice here. Or we could talk about major sector ADB. That's the unshaded slice. There is a commonality, though, with arc length. Just like arc length, sector area is proportional to the arc measure. And it's also actually proportional to the arc length. We can say the area of your pizza slice of the sector divided by the area of the whole circle, that's the same ratio again as your arc measure over 360. Here's an example involving sector area. They want the area of sector UV. That's this smaller slice here. Pause the video and see if you can figure it out using that proportion we just went over. All right, so for this one, since we want sector area, we're going to need the whole circle's area and the arc measure in order to set up our proportion. For the circle area, they gave us the radius, so we can do pi r squared or pi 8 squared. That comes out to 64 pi for the area. And then for the arc measure, we've got 70 degrees. So setting up our proportion now, we can say sector area of UV divided by 64 pi equals 70 over 360 degrees. Cross multiplying here, we've got 64 pi times 70. 64 times 70 comes out to 4480, so that's 4,480 pi divided by 360. Let's do that now. Here we go, and let's press enter. Comes out to 39 point, let's see, we'll call this 10. Now some of you might be wondering why we don't need the parentheses up here on the top of the fraction. Well, we want to multiply 4480 times pi and then divide by 360, and that's exactly what we're doing if we just write things in order with no parentheses. So we can get away with it on the top of a fraction, but not on the bottom. So again, 39.10, and that'll be square inches. Watch your units. Now we're dealing with area, not just a length. Here's another one for you to try out. We're trying to find the area of the whole circle C based on this sector area and this central angle. So if we're trying to find out the whole circle's area, we need a sector area, which they gave us, and we also need an arc measure. So our sector area, 35. And then for the arc measure, some of you might be saying, oh yeah, 40 degrees. Hold on, not so fast. This is the arc that goes with the minor sector. But they didn't give us the minor sector. They gave us the major sector, this whole thing. So we actually need the arc for this major part here. That's going to be 360 minus 40, which is 320 degrees. So be careful. Make sure that whatever area you have in your proportion, you've got the same corresponding arc for that. So then we'll have 35 over the area of the circle equals 320 over 360. So that's 360 times the area equals whatever 35 times 360 is. 35 times 360 comes out to 12,600. And then dividing by 320, we're going to get an area of 39.38, and that'll be, let's see here, square meters. We're going to wrap this one up with a nifty real-life problem. The apparent size of an object is the angle it encloses in our field of vision. So here's you. Here's your field of vision. Here's Jupiter. And here's the portion of your field of vision that Jupiter takes up. Now, this little slice here has a central angle, if you will, and that central angle is what we refer to as the apparent size. So, let's say that the apparent size of Jupiter is 0.01 degrees. Wow, that's pretty small, but then Jupiter is very far away, isn't it? The distance to Jupiter, in fact, is about 800 million kilometers. Ooh, big distance, and we put it in scientific notation to fit it there. We want to know what the diameter of Jupiter is to the nearest 10,000. Now, I guess one way to figure this out would be to fly to Jupiter and cut like a giant hole through the center of the planet, take out a giant tape measure, and measure it. There's got to be a better way, though, right? So if we think of this whole thing as kind of a piece of a circle, and then we think of this as a sector, and just kind of move it down here so we can see it better, the diameter of Jupiter, we're basically looking for this arc length here. Yeah, it's curved, and the diameter is technically straight, but it'll be close enough. I mean, you're hundreds of thousands of kilometers away. So go ahead then and find this arc length. All right, let's see how you did. So for arc length, again, we need to know the circumference. So that'll be 2 pi times 800 million, which will be 1.6 billion times pi. So we can say arc length over this number here equals the angle 0.01 degrees over 360. So let's cross multiply. In fact, we really just need to multiply 1,600,000,000 pi times 0.01. Doing that's going to be pretty easy. We're just going to move the decimal over by, let's see, 1, 2. So that'll be, how many zeros? 1, 2, 3, 4, 5, 6. It'll be this number right here. We just have to divide this by 360 now. So we've got 16 million pi divided by 360 equals, they wanted the nearest 10,000 kilometers. So this is approximately 140,000 kilometers. And we didn't even have to go to Jupiter. Awesome. This concludes our lesson on arc length and sector area. Until next time, this is Mr. Sutton signing off.